Shooting it raw?
Yes. Shooting it raw.
Well, I would say that to me, at least as I'm getting older and older, the photography for me is the window to the history. And as you mentioned correctly, like 50 years ago, or even not 50 years ago, was not so easy to take pictures. You had to have the camera, obviously. You have to have the film, not the digital format. And you have to go through all the process to get the picture. And I believe that then people, they had to think twice if they want to take this actual particular picture or not. And to me, it seems like the older pictures are better than the new pictures. And I think it's because people put simply more thoughts into what kind of pictures are taking. And personally, for me, it's the window to history.
I'm in the padded room. I'm in the padded cell. Why am I in a padded cell? Because I can't get out here unless I get 1,000 subscribers. So please subscribe to the podcast, and then maybe they'll let me out. And to celebrate, I'll eat a whole Carolina Reaper and film it so you can laugh at me. So please, subscribe, share. Help me get out of this padded cell.
Great. Jan. Okay, so Jan Hafner.
So, and what is the photography to you?
Well, at the moment, I mean, photography, I believe human beings are language producers. We can't escape making language. And what we use as the signifier, in some cases words, or photographs, or sculpture, or anything, you have the signifier represents something else, a signified, right? So a photograph can be nothing. It can be garbage. A lot of words are nothing and garbage. But a lot of words are poetic, are profound, and a lot of photographs are poetic or profound. So that's how I think of photography.
Well, I don't know if it's still the case, but in past, certain portion of photography was considered art, and there were galleries, they displayed photographs. And even today, some of the famous photographers from the past century, if you have the original photograph taken by them, you might make some quite money.
Sure.
So
sure.
it's it's the art, yeah.
Yeah. So Jan Hafner, yes, that's how you say your name, Jan Hafner? Or Jan? Jan, of course.
Yeah,
Jan.
Yeah.
Okay.
Yeah.
Are you Czech? Are you Are you German?
Yes. Yes. Yeah. How did you know I'm Czech?
Aha.
How did you know I'm Czech?
This isn't my first rodeo, and you're not my first cowboy. So I've met many Jans before.
Yeah. Well, it could be Dutch.
Okay. But so
yes.
So
correct. Yeah. Czech.
Great. So just to share with the world, where in the world are you? This is the first time we're speaking. Where are you right now?
Right now, I am in my office, as you can see on the video, and the office is on campus of University of Hawaii at Manoa.
Wow.
Which is on island of Oahu, which is a state of Hawaii.
You are the first person, I think, who has been on the podcast who lives in Hawaii, and for me, that is such a thrill. I'm really happy to talk to you, and we're going to get to know all about you through your photographs. And the main issue of the podcast is, if we only have one life, which I believe we do, how do we make each second count? Because if life is a gift...
On this earth.
Yeah.
Yeah. Only one life on this earth. Yeah.
Yeah. And so of the pillars of the podcast, one of them is conservation. And so the way we met was through some of the conservation people that I know said, oh, you should speak to Jan. So here we are. And let's dive into your first photo, okay?
Well, I picked 3 photos as you suggested that probably not more would work. And I think there is a kind of story.
Yeah.
At least I think that I have a story to link all those, all the 3 photos together. The first one is just the picture taken in North Pacific. I think it was 2016 or 17 by one of our volunteers, sailors.
Wow.
And the idea actually is coming from our partners from the Ocean Voyaging Society, Mary Crowley, and she's passionate about cleaning the ocean. I like the ocean as well, and we are trying to help on the science part. So back to the first picture. This is just to show what can you find floating in the ocean. Of course, now there are zillions of similar pictures, even more scary than this one. And essentially, my point or what I would want to convey through these images, ocean is in trouble because of this stuff, and it's not helping the marine life.
Yeah.
And we should do something about it. So that's the primary motivation of why I picked this picture.
I'm with you 1,000%. So I need to describe the photograph for listeners, which it's a podcast, which is audio, and who knows. But okay, so the image is utterly beautiful, right? So it's aesthetically, it's an incredible image, and yet it is, there's something otherworldly and disturbing about it. So the color tone is very cold white, and the black is very bluish. So the tone of the photo is it leans on the blue side, and it's the photographer or the diver is photographing up to a sky that is probably overcast while they're diving. And above them is this mess of what looks like to be nylon rope. It could have been a net, a ghost net that just got all tangled up in itself. And all around it are various species of what looks like reef fish. Maybe about, I don't know, a good 50 or so fish, roughly from the size of a tennis ball to the size of a large loaf of bread. Maybe they're bigger. So yeah, it definitely conveys like the mess of ropes. Looks like almost a beautiful sculpture of this very strange thing floating close to the surface, and around it are all these fish. But it definitely conveys this tension and the issue of we just have garbage floating around in the ocean, and it's under the surface, so we don't see it. So luckily we have somebody there to photograph it. So what else would you like to share about this photo?
Well, actually, there are 2 similar pictures like that, showing the floating stuff in the ocean. And but as I said, one part of the message and why I picked those pictures is just to show what's happening to the oceans.
Yeah.
And the second part, probably I might go through the second
later
picture to get to the whole thing, what is our science. But anyway, let's start from the beginning. As we suggested, we have this stuff dumping in the ocean for decades already, since the invention of the plastic, which happened sometimes in 1950s on a massive scale. And actually, this picture doesn't show the whole problem because I had only 3 pictures to show. This is the big stuff, and it's kind of easy to understand. And if you look on the second picture, you can even see it floating on the surface, not necessarily under the surface of the water, but also there is a small stuff we do not normally see unless we would use some nets, and we would sample, and we kind of like scoop through the water on the surface, And with a very fine filter, we can capture the other spectrum, those very small particles of plastic.
Mm-hmm.
And we might, not normally, because not as easy to see if you are on a deck on any boat, you probably won't even notice it.
Yeah.
But it has impact on marine life, as you can imagine. Those are little pieces, maybe like 1 millimeter, 2 millimeter,
Mm-hmm.
or even smaller. And it is ingested by the small marine life, like small fish. And of course, by the process, we call it biomagnification
Yeah.
or bioaccumulation. It progressively gets up to the through the food chain up to the big fish like a tuna
Yeah.
or mahi, and of course all that's plastic is loaded with organic chemicals. I think they are called plasticizers.
Mm-hmm.
They are changing the quality, or they are changing the property of the particular product and particular plastic. And of course, they are reaching into the water. And if they are in this, inside fish, inside of tuna, obviously they are reaching into the tissues.
Yeah.
And then we already have a problem with the mercury. Probably you know that's accumulated in the marine life, and there was a big issue quite some time ago with mercury pollution in the ocean.
Yeah.
And now, in addition, we have this plastic. Well, if we are going all the way back to the beginning, the issue of marine debris was there since the beginning of the oceans. But the difference is before invention of plastic, most of the marine debris was just natural stuff. You can imagine if you have a big torrential rain and you have a flash flood, it would sweep timber
Yeah.
through the rivers into the ocean. That's the natural wood.
Yeah.
And that's how actually some marine life spread from one continent to isolated islands through rafting. That I think it's called rafting, that they jump onto this marine debris piece and they are transported from one place to another. However, as I said, the problem with plastic is natural materials, they naturally decay after some time. You cannot expect the wood would last forever in the ocean. But the plastic is just the opposite. It's designed to very last.
Last very long.
Very long. Exactly. Thank you. Well, just to give you some idea how long they can last, in 1970s, NOAA did some experiments. They released plastic cards with inscriptions,
Okay.
and the idea was to study the currents, kind of passive way, and whoever would find them would report back to NOAA. It was in 70s.
Right.
They are still being found today.
Wow.
So it's 50 years.
Yeah.
And so far, all the estimates on how long the plastic can last in the environment is based on laboratory tests.
Yeah.
And so far, any plastic ever made is probably still intact somewhere, either in landfill or floating in the ocean.
Yeah. So Jan, okay. So here's what's interesting to me, because we just meet. You have your whole story that's led you through your life, and you're working in Hawaii, which is one of the... Sorry about that. Just the neighbors are a little bit loud. It'll be edited out. But okay, so Hawaii has this presence, this mythology, this reputation, this place culturally in the world where people are connected to the oceans in a way that we don't see most other places. So why don't you tell us the story of how you got there? From my eyes, you live a privileged life. You know, you live a beautiful life in which you can go and dedicate your energy and your time and your attention from one of the most remarkable places in the world. So how did you end up there?
As you mentioned, I'm from Czech Republic, which is a landlocked country, and we do not have the ocean.
Uh-huh.
Last time we had access to the ocean was when my grandma was little, under the Austrian-Hungarian Empire.
Okay.
But it's all gone. So I always, even though I have not seen it as a kid, I always liked the ocean.
Mm-hmm.
And the first chance to see ocean I got when I was in mainland at school in Gulf of Mexico. But then in 1999, I went to the conference here. It was a NASA project, and I got a chance to come for 2 days. And I love the ocean and the landscape in Hawaii here so much, so I decided to simply come here
Nice.
for good.
Wow.
And it happened 2 years later.
Okay. And so what did you study? What's your career?
Well, my background is in atmospheric science,
Wow.
and that's essentially what I do more or less here now, because I don't work only on one particular issue on marine debris, which is the realm of physical oceanography,
Yeah.
but also on other projects related to climate change, and so forth. So that's my background.
Okay. I'm really happy to have met you. So in 2000,
Likewise.
So it's quite interesting. So for example, there's something interesting about people who are landlocked, who somehow gravitate to dedicating themselves to marine and ocean life. So, for example, there are many Canadians who grew up in Toronto, for example, or who grew up in Montreal, like myself. The closest ocean is hundreds or thousands of kilometers away. So it's quite interesting that there's something with the ocean that it profoundly affects, I think, people. It's hard not to be moved, I think, by seeing how big it is and how, we only see the surface. So we have to work very hard to appreciate what's under the surface. And so, okay, so there's the headlines of microplastics and then the macroplastic, for example. What would you say is the greatest source of the large plastic that we see in the ocean?
Well, let me put it this way. I think there are two major sources: land-based and ocean-based. And what you've seen in those pictures is mostly ocean-based. That means it's coming from the fisheries. That's all derelict fishing gear, lines, and the nets.
Mm-hmm.
But that's not the whole story. Land-based is probably even bigger in terms of weight, but it's so spread out. It's not only the microplastic, the pieces we barely can see, but you have pieces of consumer plastic like wrappings or bottles, and those usually end up on beaches or are breaking down until there are those small pieces floating in the ocean.
Right.
And now the question is how to do about it.
Yeah.
And the simplest solution is to stop the influx.
Right.
I'm saying simplest, but it's not that simple.
No, it really isn't.
Because even with the recycling, with everything, there are always accidents.
Sure.
You have the garbage can. You close it, everything, and that's the same like with traffic. You have a traffic laws to prevent the accidents. Accidents happens no matter what. Look on the safest industry in the world, nuclear energy, and we had so many accidents already.
Yeah.
So that would happen. Yeah.
Sure.
However, we can do a little bit more to stop stuff coming into the ocean from land.
Right.
And the easiest way is just to put some capturing devices in the big rivers, and that would reduce the inflow.
Okay.
Regarding the ocean-based, that's mostly fisheries, and that's difficult to. I don't have a clear idea how the fisheries actually work. I've never been on a fishing boat, and I don't know what is the.
Well, I think
what is their angle?
Well, I think the issue of the ghost nets. So I mean, really, a fishing boat goes out. They just drag or release huge nets that damage, get caught, get stuck, whatever. So they just cut and free them, and then they've got this huge net that is essentially a means of capturing fish. That, you know, it's a really counterintuitive idea that fish caught in a net can drown and die, and so that's one of the impacts. But then, as you say, these nets are also just like the plastic themselves, which are toxic, float, stay, leach out their chemicals, but also break down either because of sunlight or whatever, or just actual physical damage and become microplastics. And it just, in total, just becomes that much more of a major issue. Now, you'd suggested before that the next image relates to this. So would you like to go to the next image? Or do you want to say some more about this image here now?
Well, let's go to the next one.
So the photo shows a sky. It could be at dawn. It could be at dusk, because the light is kind of warm. It's essentially 1/3 of the image has this 1/3. The top is the sky with a bit of cloud. You can just see it's kind of broken up cloud, but you can see all the way to the horizon. And then the bottom 2/3 of the image is the ocean, and it's reflecting some of the sky, so it's kind of warm. And what the bulk of the photo is this mess of, it's like a little island, or a large enough island, probably the size of a bus, or whatever. It's just this big blob of plastics that have been kind of collected. So it's like this weird looking monster of white and green and yellow and orange plastics and black and rope, all just kind of tied together as if knotted into this huge, gross, floating marine debris. So how would you like to frame this photograph for a listener?
Well, actually, I think that my intention was to start with this photograph. Essentially, it just showing, going back to the original idea, showing what is happening to the oceans. What can you find floating on the surface? And we talk about these huge blobs of nets and lines, and we talk about the small pieces. Actually, speaking of those big blobs of floating derelict fishing gear or ghost nets, they have, because that's what we learn through our project. They capture the fish, and as you mentioned, they kill marine life, but also they promote the marine life, because it seems marine life is attracted to anything floating.
Yeah.
And actually, it's well known, probably you already know it, and probably listeners as well. There's a specific term for these devices that are called fish aggregating devices, and essentially any floating platform provides a little oasis of life in the ocean. Now the question is, what is the net benefit? And we believe that the net benefit is actually doing more harm to the marine life than good.
Okay.
And again, if you go, I will come back to this idea of floating marine debris and marine life, because that's the part of our now ongoing project, and it's related through the second picture. Actually, it's a figure, not the photograph, created by the computer, and it shows kind of colorful cloud spread through the North Pacific, And actually, what does it show? It shows our simulation of spread of tsunami marine debris from the tsunami that hit Japan in 2011.
Okay.
And well, we always recognize, and we always, when talking about this, is that it was a tragic event, and many people, they lost their lives, and many more lost the houses.
Mm-hmm.
But if we look at it as a experiment, natural experiment, because unlike on a general marine debris, if you see the blob of fishing lines and nets floating, you don't know where it came from.
Right.
It could be floating there for a year, 10 years. It's not real. So far, we don't have any exact methods how to tell. We can just guess. However, in case of tsunami in Japan, we knew the exact location and we knew exact time.
Mm-hmm.
And in addition, many those items could be directly traced back because they are different. It's not a regular garbage what you might find on beach anywhere, because they were different. Suddenly we see different types of debris coming into first on the west coast of North America, Alaska, Canada, and states of Washington or Oregon.
Yeah.
And they first got those big oyster buoys, huge buoys,
Mm-hmm.
and then the other items followed, including things like fishing boats with registration numbers.
Yeah.
There was a case with a floating container that had a motorcycle inside, and again, we have the number plates. You can trace it directly back to Japan, and there were many, many other indicators. When you see unusual type of debris coming in a time frame we expect it to come, that's most likely from the tsunami.
Yeah.
But what did to us? So we learn how different types of marine debris, how do they travel, how do they respond to wind and current differently.
Yeah.
And this effect is called windage. If you can imagine, if you have a light buoy sitting very high in the water, probably the current is not as important as the wind.
Okay.
And that's what happened with those oyster buoys. And if you have the fishing nets, like in those images, those photos I sent, you can estimate the current is important, maybe more important than the wind.
Yeah.
And that's how the so-called garbage patches are generated.
Mm-hmm.
It is the convergence by the currents. Actually, wind is diverging from those so-called garbage patches. So, ocean, in terms of currents and wind, is sorting out those debris for us.
Right.
Most likely, if you go to those so-called garbage patches, you might see one or two, those high windage objects sitting high in the water, but mostly it's filled with derelict fishing gear, like in those pictures I showed.
Okay.
That was one kind of knowledge we gain from this event. The second one was even more surprising, as coming back to the marine debris and marine life. There was the case in Japan, was a coastal town, Misawa, and they had floating docks for docking fishing boats.
Yeah.
There were 4. They were identical. Probably you heard the story. After the tsunami, there were none left.
Okay.
All 4 were swept away. One was found a couple months later. The time frame escapes me completely. In Washington State, other one in Oregon, and the third one was found floating north of Maui. That's the next island here.
Okay.
And actually, it was videotaped because the fishermen came there and actually walked on the dock, it's floating dock.
Yeah.
They took the videos. And of course, like probably as we discussed about the floating marine debris, they attacked marine life. The marine life was abandoned around those floating docks. Those 2 who washed up on the beaches on Washington and Oregon, the biologists have a look and they found Japanese coastal species on those.
Right.
Of course, that would not be that surprising because they said, okay, it's coming from Japan, they should be Japanese coastal species.
Sure.
However, what was revealing is some of those individuals, some of those specimens were younger than the travel time from Japan. And we knew the travel time of Japan because we knew the time when those dogs were lost.
Right.
So it means, on the conclusion, those coastal species were thriving and reproducing while on the way to the west coast.
Yeah.
And that kind of strange, not strange, kind of interesting hypothesis about ecosystem in those garbage patches, because we are dumping this stuff into the ocean for, I don't know how many years, 50, 60 years. And suddenly, because the coastal species can get attached and survive on those floating pieces of marine debris, especially those fishing nets and lines, and they are collecting in the garbage patch. For instance, in our case, we look on North Pacific garbage patch.
Right.
So now the question is, do we create a unique ecosystem in the middle of the pelagic zone, on the middle where there should be no coastal species at all? It's all pelagic. And actually, that was the project we continue after the tsunami. With biologists, we have a look at some. They took the samples from some of those nets because for the cleaning purposes, we had volunteer sailors looking for those nets. They tagged them with satellite trackers.
Yeah.
And later, Mary Crowley with Ocean Voyaging Institute, she chartered the cleaning boat, and they went and with big boat with big crane, and they were picking up those nets, taking samples.
Right.
And of course, we found, or biologists found, there are more coastal species than the pelagic species on some of those cases.
Right.
So that was kind of revelation for the marine biologists, that with all that stuff, now we are altering, or we are changing the ecosystem in the ocean.
Mm-hmm. What is so for example, on the one hand, there's the science, right, which is about making the clear observations of what's actually happening. So what is happening? What can we see? And not to project and not to extrapolate some kind of moral or some kind of guiding decision about to either bias our understanding, but just to say, okay, well, this is what it is, this is what's happening, and this is what we see, right? So in terms of your work, because on the one hand, you said that your training is very much rooted in atmospheric science, and yet the work that you're doing is very much anchored in the oceanic physics or whatever. So what is your driving interest, really?
Well, speaking of ocean and atmosphere is forcing the ocean on short timescales. Mm-hmm. And of course, the ocean has the feedback on atmosphere as well. And so that's kind of interconnected. My colleague, who is actually principal investigator on all those projects, Nikolai Maximenko, is oceanographer. I am atmospheric scientist. So we actually meet at the surface.
Okay.
On the interface in between ocean and atmosphere.
Sure.
So you would not have the currents what we have in the ocean without atmosphere, and vice versa. The atmosphere, the climate in certain places would be different without ocean currents, as you can.
Right.
Classical example is the Gulf Stream. But speaking of on a different level than science, as I mentioned, I like the ocean, and I don't want to be polluted and marine life be disturbed in the ocean, because we are already losing many areas, especially coastal areas,
Yeah.
due to human factors. You can imagine the runoff of pesticides,
Yeah.
for instance. That was one example. You might have the other examples how the coastal areas are being damaged by human action.
Yeah.
So that's my kind of motivation beyond the science. Well, you can do science on anything, but it's not much as fun.
Absolutely. But like, for example, a couple of weeks ago on the podcast, I had Charles Ade, who ends up, he's from Nigeria, ends up working in China, in mainland China. And he's doing the chemistry, marine science, and specifically looking at the chemistry of what's happening in the North Pacific, right? So how does the North Pacific act as a carbon sink? And what are the factors that influence that? So his connection, his work, and his driving sort of interest is very much in terms of climate science, right? And so a lot of what I'm hearing from you is more of the interest also essentially on the conservation side. So the impact of toxicology, impact of human factors on animal species. So how much of your work is on the conservation side, either be it on an organization? Because so my connection to Hawaii from running shark rescue was I was very much connected to a lot of the people doing shark conservation. And so so what part of marine conservation are you really sort of attached to and working in?
Well, I'm just thinking how to start to put it in. One of the kind of mottos, or one of the ideas is you cannot manage what you don't understand. So we try to provide the understanding for not just the scientific community, but for people who actually do the work to clean up or to save or trying to improve the condition in the ocean.
Yeah.
So we, for a long time, we've been partnered with, I mentioned it already, Ocean Voyaging Institute.
Okay.
With Marie Crowley, and she's passionate about cleaning up the ocean. And of course, the ocean is big, as you can imagine, from Honolulu to the West Coast is 2,000 miles.
Right.
And if you want to clean it, it's probably a good idea to know where to go. So ship time is not cheap, and you don't want to spend tons and tons of fuel and wasted it on, not effectively do the job.
Yeah.
So our science or our kind of goal, or what we are trying to do, is to use our knowledge about movement of different marine debris and provide the data to those who are actually going there and do the cleanup. Of course, with their feedback, we learn more, as I mentioned, about the biology, because if you pick up the big fishing net, so cleaning it from the ocean, it doesn't take much to take the samples. And we have the samples of marine life from places which are not so easily accessible. You cannot probably go every day in the middle of the garbage patch and take the samples. So it takes certain effort. So that's the other aspect, how science is helping the real life, and real life is helping the science.
Nice. Okay. Well, okay, so because you said helping the science, let's move on to the third photo. Now, in this photo, you have already made reference to it. It's not really a photograph. It's an illustration. And what it is on the left is you can see the kind of the outline in white lines of the Pacific with Japan and China on the left, and then you could see the north with Russia, and then the sort of the Alaska, and then the west coast going down to California and Mexico on the right, and the little dots of islands right in the center-ish. And what we see is a kind of so it's in black and white. So that's the main field is black, and across it is this really quite beautiful rainbowish spectrum going from dark blue on the left, sort of really reaching out towards Japan, going into greens and yellows, and then red hitting on the right, which would be around, I guess, Oregon, Seattle, British Columbia. So please interpret, you had started talking about it earlier, and this is from the University of Hawaii. So what is the significance of this illustration? Why you made reference that this was going back to the tsunami, and yet you don't actually see a presence in Japan specifically, even though you can see that the trajectory must have started around Japan. So how do we understand this graphic?
Probably I mentioned already that this event, tsunami in Japan, helped us to understand how different objects move differently in the ocean. Mm-hmm. And that's shown on this image. It's purely based on our modeling data, mm-hmm. our modeling program. And whatever you see, the spectrum from blue all the way to red, that's the scale of so-called, we call it windages. So it means how much is the effect of wind on movement of the trajectory of this particular piece of debris. So whenever you have, for instance, blue, you see it is closer to the Japan than the red one.
Yeah.
And it's because it's moving with the currents that are generally slower than the wind. And if you're going to go through the rainbow, going up to the green, yellow, and red, you see the red is far ahead on the east or hitting the coast of North America.
Yeah.
And of course, this is all based on our modeling algorithms and our modeling program. Mm-hmm. But again, we are coming back to the real life. We used the reports from coastline of various types of debris to validate our model.
Right.
So it's not only just because anybody can do any model, and then the question is, what does it mean?
Right.
How does it relate to the actual world? And we use those reports mostly from coastline because those are the most easily obtainable.
Yeah.
And more people go to beach than go in the middle of garbage patch. However, coming back to the cleaning efforts again, with reports from those cleaning efforts about the concentration, how many nets, what is the total weight were collected in different areas. Again, we can go back to our modeling data and we can calibrate our simulation to reflect, to represent the reality. So I guess kind of like a feedback. We provide the scientific information to real people or real world, and vice versa. We get a real feedback, real data back from the field because you need some ground truthing in any modeling.
For sure.
And actually, that gave us a confidence that whatever we did, with some kind of little small adjustments, more or less, we can get the overall picture regarding the marine debris in the North Pacific.
Okay, so only because I'm a dummy and I don't know this, but okay, so if I imagine the water column, and that's, let's say, 1 kilometer thick, with the surface going all the way down to about 1 kilometer, and you have debris coming in, and we'll say we're only paying attention to organic compound plastics, right, from styrofoam to hard plastics, or all into the whole range of plastics. How much of the analysis that you make, how much is water depth a problem? So, for example, is the plastic essentially congregating or concentrating at the surface, or is it pretty much across the whole depth of the water column?
Well, so far we have not included that into our modeling effort. However, we know that there is a variability of plastic concentration in a water column, and it's not static, it's dynamic. As you can imagine, with increased wind, you have increased mixing, and certain type of marine debris, specifically the micro, the very small pieces, they will get mixed very deeply. In some cases, there are reports 100 meter or more.
Okay.
That's the mixing. However, you can imagine even taking the observation from the surface is not that simple task.
No, for sure.
And now you add another dimension, so we have even less data, actual data from the water column. So this is still one area of research which is open, and we need to get more data on that.
Of course.
Well, but speaking about those big, the micro, those huge fishing nets and lines, they are not as sensitive to mixing. Of course, there are some kind of variation, but you can imagine it's not so easy to put a huge bulk of fishing nets to 100 meters depth. Might take it's not that easy. But a small piece of speck of plastic, it mixes very easily, very quickly. But we know that it exists. We kind of recognize this effect. However, to quantify it, we still do not have enough observation. We don't have enough data.
Right. So how large is the team that you're working with in Hawaii?
Okay, well, I'm glad that you asked. Team in Hawaii, I'm working with my colleague Nikolai Maximenko is the only one from Hawaii, but everybody else is from somewhere else.
Okay.
We have kind of a big, diverse team that encompasses physical oceanography, the wind, atmosphere, the biology, conservation. So I would like to acknowledge those as well.
Sure.
Mary Crowley from Ocean Voyaging Institute. We have Rebecca Helm from University of North Carolina, people from Smithsonian Institute, Sheila Zabin, we have Lindsay Harem, we have biologists from Williams College, James Carlton, we have the two scientists from Canada, both are from the Fisheries and Oceans Canada.
Yeah.
It's the Cindy Wright and Catherine Murray. Of course, we have scientists doing the oceanography, like Andrei Cherbina, he's from University of Washington. Luca Centurioni, he's expert on drifting buoys. So there are many people.
I mean, we can't go through everyone, but would you say that there's this is an effort of, say, 100 people, of 1,000 people, of...
I would say maybe about 10.
Okay.
Well, because each of that other person might have reached somewhere else. Like for instance, Mary Crowley got in touch with Doug Woodring, and he got in touch with you, and now we are in touch. So it's kind of...
Yeah, it's a network. It's a network,
yes.
So how do we inspire somebody else, right? Like how do we kind of get people to listen to this passively, but then take it to the next step, which says, well, you know what, so for example, for a lot of people, and because of the pandemic, it's made them more introspective. And for a lot of people, they're like, okay, maybe my time is limited and I do need to focus on something that I care about. And I do care about climate, or I do care about the oceans, or I do care about biodiversity. There's so much to care about. So what would you suggest? Like your journey, your road, which went from the Czech Republic to Hawaii, sounds like a fairy tale. It sounds, and I realize when you live it, it's life. It's just life. But from somebody from the outside, it's kind of like, wow, this guy lives in Hawaii. Like, that's amazing. So what What kind of advice could you give somebody who is 20 years old or 30 years old, 40 or even 50 years old or 60 years old who wants to reinvent themselves in that direction? What could you give any advice?
Well, it's a good question. There could be a short answer or long answer. If I take the step on the short one regarding the marine debris and marine life, probably the best motivation, but at least for me, would be if the people would see it on their own eyes. Picture is it's okay, but today, as probably mentioned at the beginning of this podcast, today we are bombarded by hundreds and hundreds of thousands of images, and now people are not very as sensitive to whatever the message is. But if you see it in your own eye, what's actually happening, it's probably a much stronger impact.
Yeah, for sure.
Which is kind of difficult because many people, they live inland, and getting into the ocean to see it it's considerable effort. It's not so simple. Maybe we can work with some educators to create some, not virtual, but because I said virtual is not as, doesn't have that impact as the real.
As a real
some
experience.
kind of exhibit. And I think some people, they already did it. They are trying or leaning in that direction to include exhibit on marine debris in various museums. And I believe there was a museum somewhere in Switzerland. They actually ordered and paid for shipment of derelict fishing gear from Hawaii to Switzerland.
Wow. Yeah, that makes sense.
However, you probably expected more philosophical answer to this question. Well, it's overarching is not, marine debris one, what. Essentially, the question is, what should I do with the rest of my life?
Yeah.
What would be the meaning? Yeah. Well, and again, there's a short and long answer. In a short answer, I would say take care of or help your neighbor.
Okay. Nice.
And it could be help your neighbor as a person, or you can help all people collectively by helping the nature or keeping ocean clean or taking care of climate or anything else. So in which indirectly we are helping everybody else or everybody on this planet.
Jan, perfect. Thank you very much. It's an hour that goes by so fast. It's amazing.
Well, that's because of you. You make it so easy.
Well, thank you very much.
Yeah, I'm always terrified to talk 1 hour, so I have nothing to talk about 1 hour. But
you just did it. So you just did it without even trying. Jan, how about I really hope one day I can come and meet you in your office, and you can explain to me and you can show me your life in Hawaii. Because like I say, from the outside looking in, it looks incredible.
Well, that's always people think the grass is greener on the other side of the fence.
Yeah. The ocean is bluer on the other side of the boat. You're right.
Yeah. Exactly. Okay.
Okay. Have a great evening. Have a great day. Okay. Bye.
Shooting it raw?
Yes. Shooting it raw.